Good morning, all of you. So let's start today's class. So in the last class, we have learned this prism, and in that we have learned this angle of minimum deviation and refractive index also. Refractive index mu is equal to sine a plus delta by 2 by sine a by 2. Okay. So let's continue. Let's plot a graph that is I versus delta. So graph that is, if we will plot graph that is I versus delta, suppose I taking on x-axis and angle of deviation I have taken on y-axis, and if you will plot the graph, you will get graph nature something like this. Okay, like this. So this one is delta minimum, this one is delta maximum, right? And this is what angle of incidence is. Like this graph you will get, that is angle of deviation versus angle of incidence. Yes. So condition for minimum deviation is what? Yesterday also I have told you. So again, condition for minimum deviation, that is in that yesterday's expression we have took I1 is equal to I2, right? So here also I1 is equal to I2, again I am repeating, and the delta minimum should be equal to 2I minus A, and the refractive index mu is equal to sine of A plus delta by 2. This is 2 is both for this A and delta, so I am keeping in the one bracket, divided by sine A by 2. Okay, sine A by 2. This is what your refractive index. Yesterday we have learned this. Next one, condition for maximum deviation. What is the condition for maximum deviation? This is very important now. We can keep this into the box and let's move ahead. So that is condition for maximum deviation. When we will get maximum deviation? Very important. Condition for maximum deviation. Condition for maximum deviation. So let me draw the diagram first. And now let's draw one normal here to the surface. And now I am incidenting a light ray so that I should get maximum deviation. So what is the maximum angle possible? Maximum incidence angle possible is what? Maximum angle possible is what? 90 degree. Yes. What is the maximum angle possible? 90. So ray will go like this. And then it will refract, and then it will emerge out of this prism. So this is what incident ray, refracted ray, and this is emergent ray. And again I am drawing one more normal. Let this keep normal with the red color. So here this is what now angle of incidence, and this angle is equal to how much? 90 degree. And this one is your angle of emergence. Even you can denote it with I2 also. So now delta maximum is equal to what here? Yes, delta maximum is equal to what? You see, this is your original ray. Can you see? This is what your original path of the ray, and this one is what your emergent ray, which came out like this. So this angle is what you are now? Delta maximum. Yes or not? What is this angle? Delta maximum. Can you see? This is what actual path of the ray, which we have incident like this. And then this one is what your emergent ray, and whatever this angle is there, that is your delta maximum angle of deviation. So if you will calculate this delta max, what you will get? This is equal to 90 plus angle of emergence minus this angle of A. What is this angle A? Prism. So you will get this delta max, right? So if now I want this E, what we want? This E, then this angle E is equal to sine inverse of mu into sine of A minus theta c, which is critical angle. So if you will find out this, you will get maximum angle of emergence. Delta max is this, and angle of emergence, if you want, either you can calculate from this formula or by using this formula. Okay. So this is what condition for maximum deviation. Next one, condition for no emergence, means light will not come out of the prism. So that is what condition of no emergence. So see here, condition of no emergence. No emergence means light will not come out of the prism. Okay. So here, this is a prism. You see this ray is not going to come out of the prism. This is what? Inside only. So then this one is your angle I1, that is angle of incidence, and these angles as usual R1 and R2. This is angle A of the prism. This is A, B and C. These two are the normal, okay, which I have denoted with the dotted lines. So these type of things they are asking in problems, so you should be ready. So for this, angle A should be greater than 2 times of critical angle to obtain this condition of no emergence, where theta C is what? Critical angle. Theta C is what? Critical angle, and this refractive index should be equal to 1 by sine of A by 2. Refractive index is greater than 1 by sine of A by 2. Then the ray will not go out. That is, total ray will be inside the prism only. No emergent ray. Okay. So emerging light is not possible here by achieving these conditions. Right? Note down. Next one is condition of grazing emergence. Next point, condition of grazing emergence. Grazing emergence means the emergent ray will be along the line, that is along the triangular line, or we can say AC side of the triangular prism. I will show you diagram. Condition for grazing emergence means how. So here it is the prism. Yes, this is a prism, and now this is an incident ray, and now this after refraction ray will go like this along the line. After refraction, how it will go along the line. So and these are the normals you can see here like this. So let's note with the dotted lines. So no grazing emergence means what? If the emergent ray is along the side of triangle, that is AC side, hai na? This is A, this one is B, and this one is C point. Okay. So here, suppose this angle is I, this one is R, and this one is I am taking as a theta C. Why theta C? Because when this light ray is incident here, this is nothing but critical angle, and this is just grazing. So this one is how much you are having? 90 degree. That is angle of emergence. Right? Why critical angle? Because yesterday also I told you in the last class, that is critical angle means the angle of incidence in the denser medium for which angle of refraction is 90 degree in the rarer medium. Same case we are going to achieve here. That's why that is critical angle. So let's see this derivation now. Here angle E is equal to 90 degree. Angle E is equal to 90 degree, comma R2 is equal to C. R2 is equal to C means theta C, है ना, critical angle. So if you want, you can denote with a theta c. Theta c is what? Critical angle. So here it is theta c. R2 is equal to theta c. You can see this is R1 and this is R2. So this is theta c, or R2 is equal to theta c, you can write. Okay, next. Now we know angle of prism. This is angle A. Angle A is equal to what we got? R1 plus R2. So R2 is what here? R1 plus theta c. Yes or not? So angle A, what you got? R1 plus theta c. What you got? R1 plus theta c. Okay, next. And refractive index is equal to, mu is equal to 1 by sine of theta c. This is also in the last class we have learned this. Refractive index is equal to what? 1 by sine theta c, where theta c is what? Critical angle. These formulas we know. Now for face AB, here, see here what I am doing. For face AB, this is air now, this is what? Glass. So 1 sine of I is equal to mu into sine of R1 for this space. You can see mu is air. This is air. Air means refractive index is 1. So therefore here it is 1 sine of I is equal to mu into sine of R1. So now this sine I is equal to mu into sine R1 is what we got from this. If we will see here, can I write like this? R1 is equal to A minus theta C. That implies R1 is equal to A minus theta C. Can you see here? So the same thing I am going to keep here now. So therefore, can I write like this? Sine of A minus theta C. Okay. Next now. So here sine I is equal to mu into sine of, this is sine A minus B formula we can use. Sine A minus into bracket sine A minus B, है ना? So what is the formula? Sine of A into cos of theta C minus cos of A into sine of theta C. Sine of theta C. Right. Okay. So now, so here what I am doing, see, this is equal to mu into bracket sine of A. At the place of this cos, can I write under root of 1 minus sine square theta C? Yes, minus. This is cos A sine of theta C. So I am keeping it as a cos A into sine of theta C. Okay. Now after this, let's move here. Okay. Or else let's go to the next page. So you got like this. Sine I is equal to mu into sine A, mu into sine A under root 1 minus sine square theta C 1 minus sine square theta c minus cos a sine theta c minus cos a sine theta c. Okay, right. Now, so what we can substitute? Let's see. This sine I is equal to mu is mu as it is. Sine A we are having, so I am keeping sine A as it is. Sine A under root. Can I keep 1 minus 1 by n square here? Yes, why? Why I can keep like that? Because we know here I will keep mu because refractive index I have denoted by mu, so no need of this n. N and mu are both are same, but I have already denoted with mu, so I will keep here mu only. Okay, so this is what mu. Why? You see, mu is equal to what? 1 by sine of theta c. So that implies sine square theta c is equal to 1 by mu square. Therefore, sine theta c is equal to 1 by mu, and therefore sine square theta c is equal to 1 by mu square. Understood why we are getting like this? Okay, minus this is cos A into sine theta c. Sine theta c is what again? 1 by mu. So can I keep here 1 by mu? Okay. So now next sine I. Sine I is equal to mu inside bracket sine A under root mu square minus 1 divided by mu square minus cos A into 1 by mu. So this is equal to mu. This is, I am taking mu square out of the square root, so I will get sine A divided by mu, sine A divided by mu under root mu square minus 1 minus cos A by mu. Cos A by mu. Okay. Now from this curly bracket, shall I take out common mu? So mu I have taken common, that is 1 by mu particularly. And what is left inside? Sine A under root mu square minus 1 minus cos of A, and this mu will get cancelled. So sine of I is equal to this one, sine A under root mu square minus 1 minus cos of A, and therefore you want angle of incidence, that is I is equal to sine inverse of this total, sine A under root of mu square minus 1 minus cos A. So this is what angle we should use, so that there is which condition? Grazing emergence. Grazing emergence means the light ray will not come outside, but it will just graze the surface. Clear? So note down this. Okay. So let's stop here. Bye for today.